everyone. Here I am going to explain you about the coordinate geometry of 10th mathematics, that is 7th chapter of your textbook. Already I introduced this introduction part of this topic, that is coordinate geometry. First of all, I want to explain some topics in the introduction part. First of all, look at here. Coordinate geometry is also known as analytical geometry, and coordinate geometry was introduced by René Descartes. You just remind this name. So René Descartes, who was introduced this coordinate geometry. Okay. So René Descartes is the first mathematician who explained and make the bond of this algebra and geometry. Okay. Here it is the diagram which explains you about the x-axis and y-axis. It makes the 4 quadrants. Here, look after here, this is the first quadrant, it is second quadrant, it is third quadrant, it is fourth quadrant. You just look after here. In the first quadrant, we have x values are positive and y values is also positive. That's why we are taking it as, in the first quadrant, we are taking it as plus. Okay, and in the second quadrant, x coordinates are negative and the y coordinates are positive. Okay, here these two are positive and here the x coordinate. Always we have to remind that the first we have to write the x coordinate and then y coordinate. So here the x coordinate and the y coordinate are positive, and here the x coordinate is negative and the y coordinate is positive. That's why I am taking here as a negative, positive. In the third quadrant, you just look after here. What is x coordinate? Negative or positive? Negative. And y coordinate is also negative. Here the x coordinate is positive and the y coordinate is negative. Here it is the third quadrant. Here it is the fourth quadrant. Hence, we are dividing this x quadrants is into 4. Okay, into 4. The first quadrant, second quadrant, third quadrant, and the fourth quadrant, just like this. And the origin, already you know that in this place, so the origin, the coordinates are 0 0 0 0. At any point on the x-axis will have y coordinate as 0. Why? Because look after here. So on any point, if you want to take 1 2 3, here it is a point. When you take one point on x-axis, what is y? It becomes 0. If you want to take any point on x-axis, okay, any point on x-axis, what is this point? 2, 0. What is the y coordinate? 0. If you want to take here -4, if you want to take one point on x-axis, what is this point? -4, 0. Always, if any point on x-axis will have y coordinate as 0. Just like that, if you want to take any point on y-axis, it will become the x coordinate as 0. If you want to take, I want to take here this point as this point. Okay, what is this point? 0, -3. What is x here? 0. If any point on y-axis will have x coordinate as 0, the equation of x-axis becomes y is equal to 0, then equation of y-axis, then it becomes x is equal to 0. Just like this, we are writing these points. Okay. Next, you have to remind that the other name for the x coordinate is also known as abscissa, and the y coordinate is also known as ordinate. Okay. When you take the intersection part of this quadrant, so it gives the null sets. Elements. Intersection means no element is common in this two anardham. Okay, so the meaning of this intersection is there is no common points, then it gives the null points. So here it will give the one Cartesian plane. This we call it as a Cartesian plane. This we call as a Cartesian plane. It is two-dimensional pictures. It is two-dimensional pictures in this. So the perpendicular of this abscissa means x coordinate, right? Abscissa, for the abscissa, what is the perpendicular distance from y-axis? Okay, abscissa, ordinate of the point is its perpendicular distance from the x-axis. The opposite to the abscissa is y-axis and the opposite to the ordinate is x-axis. And in this chapter especially we are solving the problems by using of these points, coordinates on the graph. So especially we are doing the distance between the 2 points, centroid, to find out the centroid, and to find out the how the points were designed. That is different. If 3 points we have, is it an equilateral triangle, isosceles triangle, scalene triangle, right-handed, right triangle. Just like that we have to find out the different points, which is if the points we have four, that is a rhombus, square, rectangle, parallelogram, trapezium. We are finding with the different manners. Okay, so that is distance between 2 points, and distance between formulas, and as well as by using of this distance formula we are finding this all, as well as in this chapter especially we are doing this section formulas, midpoint formulas, centroid formulas, as well as the area of a triangle we have to find out by using of this chapter. And also we have we are used to find the slope of the lines. Okay, so for the first exercise I'll explain different kinds of distance formulas for you. Not only this formula, it is the distance formula for any 2 points. In that different manners, different types of formulas of this distance we can use. If the coordinates are become, sometimes it becomes 0, sometimes it becomes same. For that conditions, what the distance formulas we are using in this chapter. Okay, I'll explain now. So now before enter into this, so coordinate geometry, first of all in the page number 160 we have one question. What is the distance between -2, 0 and -6, 0? You just once look after this. In these 2 points the y coordinates are 0. Just look after. In these 2 points we have y coordinates are 0. Only we have x coordinates. Only we have x coordinates. If for a graph, look at here, for a graph, if any 2 points which is on x axis, only it gives the y coordinates are 0. Yes, if any point which is on x axis, then the y coordinates which becomes 0. Then the distance formula it is equal to, that is here the distance, once you just imagine any length or distance is not expressed in negative values. First of all you just remind lengths, weight, time, distances, we can't measure this values with negative numbers. So here we are for the positive values we are taking it as a modulus. Okay, so this modulus, for this we call it as a modulus of only x coordinates we have. So x2 minus x1 I am taking as a formula. Why? Because look after here, what is the distance between these 2 points? What is the distance between these 2 points? What is the distance of this first? 6, right? Up to 6 centimeters. What is the distance of this one? 2 centimeters. Then what is the distance between these two? What is the distance between these two? 6 minus 2. 6 minus 2. Then it gives 4 centimeters, right? The distance between these two are 6 minus 2. Why? Because y coordinates are 0 and x coordinates, the first point is 2 and the second point is 6. That is, this is x2, this is x1. The points I am taking it as, look at here, the points I am taking it as x1, y1, x2, y2. So only we have x2 and x1. When I am subtracting this x1 by x2, then I will get the actual distance between the 2 points. Hence the formula it becomes x2 minus x1, that is modulus of x2 minus x1. modulus of x2 minus x1. When you will take this distance formula, it is the distance formula, distance between any two points. When the x coordinate it becomes 0, when the y coordinates are 0, when the y coordinates are 0 in the 2 points, then the formula for the distance between 2 points becomes modulus of x2 minus x1. Modulus of x2 minus x1. Look at here, the general. Okay, it is very important. In general, for the points A, the first point, x1 comma 0, B, x2 comma 0, here the y coordinates are 0. On the x-axis, the distance between A and B is modulus of x2 minus x1. Is it clear? Yes. If in the 2 points y coordinates which becomes 0, then the formula of the distance between 2 points is modulus of x2 minus x1. Why we are using this modulus? Why? Because there is no negative values for the distances. Hence, this modulus which makes the negative values into positive. That's why I am using this modulus. Okay, if suppose the points which is on y-axis, then the x coordinates are 0, just like this. Look at here. Similarly, the distance between 2 points when 0 comma y1, 0 comma y2. Here in these 2 points, you just compare these two. Here the y coordinates are 0, here the x coordinates are 0. Then the formula it becomes y2 minus y1, that is modulus of y2 minus y1. Is it okay? For example, here the points which is given as an example, that is 0 comma 2 and 0 comma 7. In this given 2 points, that is 2, 7. These two are y coordinates and x coordinates which becomes 0. So what is the formula? y2 minus y1. Hence it becomes 7 minus 2, that is equal to 5 units. I think you understand this well. Okay, the distance between the 2 points formula, when the y coordinates which becomes 0, then the modulus of x2 minus x1. When the x coordinates which becomes 0, then modulus of y2 minus y1. Before starting this, do this, you just write these 2 points. Okay, before starting this, do this, you just write these 2 points, and also you just first write this point and then write this example one. Example. Then after, for the first point, after this, for the first point you just write this example. Okay, and for the second point you just write this example and solve it. Okay, and solve these two. Okay, after completion of these 2 explanations, you just write this, do this. You just look after, where do these points lie? Where do these points lie? Okay, so look at here, do this in page number 160. Do this. So first page number 160, do this. First question is where the points which is lies. The first point is minus 4 comma 0, 2 comma 0, 6 comma 0, minus 8 comma 0. So the points we have to identify in graph, right? You just look out here, x-axis, y-axis I am drawing. The horizontal line which is x-axis, and the vertical line it is y-axis. So 0, 1, 2, 3, 4, 5, 6, 1, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, minus 8. Okay, 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4, right. So the first point is minus 4 comma 0. Minus 4 comma 0. This is the first point. Second point 2 comma 0. It is the second point. 2 comma 0. 6 comma 0. It is the third point. Minus 8 comma 0. It is the fourth point. Where the points which is lie? The points which lies on x-axis. Why because x-axis? Because y coordinates are 0, right? In all the points the y coordinates are 0. If the y coordinates are 0, where the points which lies? On x-axis itself. Okay, it is the answer for the first question. And the second question, what is the distance between the points? Okay, the distance between the 2 points. What are the points? Given that the points are minus 4 comma 0 and 6 comma 0. Here x1 y1, x2 y2. Here the y coordinates which is 0. If the y coordinate 0, what is the distance formula? Here it was. If the y coordinates are 0, what is the distance formula? Here y coordinates are 0. Hence, the distance formula is modulus of x2 minus x1. That implies, what is x2? 6. What is x1? Minus 4. That implies 6 plus minus of minus plus 4 modulus of 10. That implies 10 units. That is the answer. Okay, just like that, you just do try this also. Look at here, where do these points lie? You just take these points just like this. Okay, just like this you take these points in a graph. Not in a graph, in the notes you just write this one like this. Okay, so and the second question, what is the distance between these 2 points? Here look after x coordinates which becomes 0 and the y coordinates are there. What is the formula you have to take here? Modulus of y2 minus y1. Justify that the distance between the 2 points on y-axis is y2 minus y1. Yes, we are justifying. When you are calculating the distance between the 2 points, it gives the same answer when you are doing with the formula of y2 minus y1 of this modulus. Okay, so just like this, do this, you just do this, try this also. Okay, next, think and discuss. In page number 161, think and discuss. How will you find the distance between the 2 points in which x or y coordinates are same but not 0? What he was telling that if the x coordinates are same, then what is the formula? If suppose y coordinates are same but not 0, then what is the formula? Right? So let us, I am giving one example to you, that is here, look after here, the distance between the 2 points. Before writing of this think and discuss, you just look after this distance between the 2 points on a plane line parallel to the coordinate axis. If the points are here, the y coordinates are same. Suppose example I am giving here, if the 2 points, that is 6 comma 1, 7 comma 1, here the y coordinates are same. If the y coordinates are same, then the formula is x2 minus x1. x2 minus x1. Okay, you just write. For this, the solution is here. For this, the solution is there here. Consider the points, the first point. For this, solution is here. Okay, consider the points a x1 y1, and B x2 y1. Since the y coordinates are equal, the points lie on a line parallel to x-axis. Then the distance formula, then the distance between the 2 points is this one. Example, write this. For this, you just write this line and then the distance between the 2 points, y coordinates is, just keep one box here and take the example, this one. And the second point is similarly this one. Up to here you just write. And example for this, here the x coordinates are same. Look at here. Here the x coordinates are same. Here example is 1, 6, 1, 7. Here the x coordinates are same. Okay, then also the formula is y2 modulus of y2 minus y1. If y coordinates become 0, then also the formula is modulus of x2 minus x1. If the y coordinates which becomes the same, also the formula is modulus of x2 minus x1 itself. And also here the x coordinates are 0 in both the points, then the formula is modulus of y2 minus y1. If the x coordinates are same, then also the formula is modulus of y2 minus y1 itself. Just reminder, on these points, on these 2 points, we have example in the next page. Look at here, page number 162. Do this. Page number 162, do this. What is the first sum? Okay, page 162. Do this. Look at here, what is the first sum? What he want to find out? Find the distance between the following pairs of points. Find the distance between the following points. Okay, first question. First question is given that the points are 3, 8, 6, 8. Here x1, y1, x2, y2. But the y coordinates are same. Here y coordinates are same. Hence, the distance formula is modulus of x2 minus x1. Modulus of x2 minus x1. Why? Because y coordinates are same. Hence, the equation, finally the answer is modulus of 6 minus 3. That implies 3 units. That's it. Second question, minus 4, minus 3, minus 8, minus 3. Here x1, y1, x2, y2. From above, here y coordinates are same. Hence the distance formula is x2 minus x1. That implies minus 8 minus of minus 4. That implies minus 8 minus of minus plus 4. That implies minus 4. But the modulus is there, no? Hence this minus 4, it becomes 4 positive value, that is 4 units. Okay. Third sum, 3, 4, 3, 8. Here look after x1, y1, x2, y2. Here the 2 coordinates. But look after here the x coordinates are same. Here x coordinates are same. Hence the distance formula is y2 minus y1. That implies, what is y2? 8 minus 4. That implies 4. That implies 4 units. Okay. What is fourth sum? Minus 5 comma minus 8, minus 5 comma minus 12. x1, y1, x2, y2. Here x coordinates are same. Hence, the distance between formula is y2 minus y1. What is y2? Minus 12. Minus y1 minus 8. Right? So that implies modulus of minus 12. Here minus of minus plus 8. That implies minus 4. Modulus, it gives the positive values, hence 4 units. That's it. It is a solution for this. Do this. Okay, example 1. Example 1. What is the distance between A 4, 0, B 8, 0? Here the y coordinates are 0. Hence the formula it becomes x2 minus x1, that is equal to 8 minus 4, that is equal to 4 units. You can do this, right? And example 2 also, look at here. The y coordinates are 0. Here the y coordinates are 0. Then the formula it gives x2 minus x1. Up to here you can write. Okay, up to here. Okay, then it is the next formula. It is very important. Why? Because look at here. Let A and B denote the points 4, 0, 0, 3. Here in the first point y coordinate is 0. In the second point x coordinate is 0. Then how the formula it changes? That is the formula which is used for this kind of, okay, I am writing here, okay, you just take that formula it as, okay, I am writing here. Let A x1 0, B 0, here x1 0 and 0 y2. Okay, just I am taking it as xy. So, and then the distance formula, then the distance between 2 points is equal to square root of x square plus y square. X square plus y square. Why? Because the distance between the 2 points here like this, here it was in right angle triangle. You just take the Pythagoras theorem. What is Pythagoras theorem? Here it is the origin, it is slope, that is hypotenuse square, that is AB square is equal to OA square plus OB square. OA square plus OB square. What is OA square? Here I am taking A as x0, right? Here I am taking B as 0, y. What is the distance between these two? X. What is the distance between these two? Y. Hence it becomes AB square is equal to x square plus y square. X square plus y square. This square it comes to this, hence it gives AB is equal to square root of x square plus y square. That is the distance formula. Just like this you have to write. After completing of this example 2, you just write this one. Okay, you just write this one and draw this figure. And draw this figure in your notes. Okay, after completion of this example 2, you just keep the heading. if you just keep the heading, that is the distance between of any 2 points which has the first point which has y coordinate as 0 and the second point which has x coordinate as 0. Then the distance formula is like this. You can write, you just write and take the Pythagoras theorem from the figure. AB square is equal to OA square plus OB square, that is equal to x square plus y square. AB is equal to square root of x square plus y square. Just like this. Don't write these numbers. Don't write these numbers. You just take in the point, in the place of this 4 you just write x, in the place of this OB 3 you just write y. Okay, just like this you just fill this formula. Then do this in page number, in the same page 162, do this. Distance between the following points. The first point is, the first sum is, what is the first sum? Given that the points are A 2, 0, B 0, 4. Just like the above example, right? Just like the above example. I am giving it is a third example to you, that is the distance formula. We have different formulas for the different types of points. So it is one kind of points. Okay. So x1, y1, x2, y2. Look at here. In the first point y coordinate is 0. In the second point x coordinate is 0. Then the formula is here from above y coordinate is 0 in A, x coordinate is 0 in B. Hence the distance formula is, the distance between the points is square root of x square plus y square. That implies, what is x square? Square root of 2 square plus y square, that is 4 square, that is equal to square root of 2 square means 4 plus 16, that is equal to square root of 20 units. That's it. What is second sum here? Second sum, square p of 0, 5 and q of 12, 0. Q of 12, 0. Here also the first point which has x1, y1, x2, y2. Here in the first point, here from above, x coordinate is 0 in P, y coordinate is 0 in Q. Hence the distance between the formula, hence the distance between the points is square root of x square plus y square. That implies 12 square plus 5 square. That implies 144 plus 25. That implies square root of 169. Square root of 13 square, square root cancel 13 units. It is a second sum of this. Do this. Here look at here. It is one kind. It is another kind. Here origin we have to take. Okay. For the origin, if let A x comma y, B is origin. B is origin. Origin means 0, 0. Then the distance formula, the distance between the 2 points are x square plus y square. The same formula. The same formula. If you want to take the distance between any point with the origin, then what is the distance formula? If you want to find out the distance between any 2 points, that which one point is the origin and the another point is the other one, right? If you want to find out that, what is the distance between the 2 points formula? Square root of, as usual, square root of x square plus y square. Then you just find out this. Try this. What is given points? Given that the points are origin. Origin means 0, 0, 0. Another point, A is equal to 7, 4. It is x1, y1, x2, y2. Then what is the distance formula? Here, one point is origin. One point is origin. Then the distance between the 2 points is equal to square root of x square plus y square. You just take this x and y as this one. That implies 7 square plus 4 square. That implies square root of 49 plus 16. That implies 65 units. That's it. Okay, it is a solution for this sum. Now we enter into page number 163. Okay, here in think and discuss, look at the question. How can you find distance between 2 points located in different quadrants? In different quadrants, if the points which is located in different quadrants, how do you find out the distance between the 2 points, right? So for that, it is a final formula which tells about the distance between the points. Okay, the distance formula is this one. So here, look at here, it is the graph which tells you that is positive values of this x-axis, positive of y-axis. These four are 4 quadrants: first quadrant, second quadrant, third quadrant, fourth quadrant, right? If we are taking any 2 points of this A and B, look at here. Okay, so if we are taking A and B, that the points are x1, y1, x2, y2. The points which is not lies on this x-axis and not lies on this y-axis. Okay, so the point which lies, that is x1, y1, x2, y2. Yes, what is the distance between these two? When you add this just like a right angle triangle and join this with the x-axis and also y-axis. What is the distance between this up to here, right? That is x1, x2. Up to here, that is x2. It is the distance between up to here, B point is x2. And up to A, here, this is the point, that is x1. Then what is the distance between these 2 points? That is x2 minus x1. x2 minus x1. That is the distance between these two, right? Here I am writing, that is R is another point which makes a right angle triangle for this AB and AR. The distance between this AR is x2 minus x1. Just like that, the point from this here to up to B, that is y2, and this is y1. Then what is the distance between these two? This is y2, this is y1. y2 minus y1, y2 minus y1. Yes, by Pythagoras theorem, AB square is equal to AR square plus BR square, just like here. Look at here. Okay, so by Pythagoras, AB square is equal to AR square plus BR square. So that is equal to, what is AR? x2 minus x1. x2 minus x1 whole square plus, what is BR? y2 minus y1 whole square. y2 minus y1 whole square. So AB square, when you write this in the square root, the square, it becomes a square root in the other side, that is AB is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. That is the formula for the 2 points when the 2 points which is in different quadrants or which is not on x-axis and y-axis. That is the final formula, that is the distance formula is this one. Okay, so how can you find out the distance between 2 points which is located in different quadrants? We can find out the distance between the 2 points by using of this formula. It is the solution. The distance between 2 points, that is which is in different quadrants A and B, then D is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square is the distance formula up to here. up to here, it is a solution for this. Think and discuss. For this think and discuss, it is a solution. Okay. Next, in think and discuss, in the same page we have another think and discuss, that is in the page number 163. That is Ramu says the distance of a point P from the origin. Origin means 0, 0. Already I said no. Given that the points which is the distance between with the origin and the other point. What is the formula? With the origin, what is the other formula? That is one point which is origin and one point which is other one, right? That is square root of x square plus y square. Here also Ramu said the distance of a point P of xy from the origin 0, 0 is square root of x square plus y square. Do you agree with the Ramu or not? Why? Why? Because one point which is 0, 0, only we have that is x1, y1, x2, y2. So when you substitute this point in here, so here we have a points, that is given points are P of x, y and origin O 0, 0, x1, y1, x2, y2. And when you substitute these 2 points in a distance formula, what is the distance formula? Distance between PO is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. That is equal to square root of okay, x2, what is x2? 0 minus what is x1? X whole square plus y2 0 minus y whole square. That is equal to square root of 0 minus x square means x square plus y square. Here it is the formula. Okay, you just write this solution, and yes, from the above I agree with Ramu. I agree with Ramu that the point P of xy and the origin gives the distance formula as square root of x square plus y square. Okay, so it is a solution for this first think and discuss. Now here in the second sum, Ramu also writes the distance formula as AB is equal to square root of x1 minus x2 whole square plus y2 minus y1 whole square. Why? We have to give the reason also for this question. Okay, so let us take one example, that is second sum in the think and discuss. So let us take another example. Let us A is equal to minus 2 comma 1, B is equal to 3 comma 5. So x1 y1, x2 y2. Let us check. First of all, AB distance is square root of x2 minus x1 whole square plus y2 minus y1 whole square. Okay. So what is the formula he was given? That is AB is equal to square root of x1 minus x2 whole square plus y1 minus y2 whole square. Let us check both. Okay. So that is equal to x2 means 3 minus of minus 2 whole square plus y2 means 5 minus 1 whole square. That implies 3 plus 2 whole square plus 4 square. That is equal to 5 square plus 4 square. That is equal to square root of 25 plus 16. That is equal to square root of 41. Here, so that is equal to square root of x1 minus x2. x1 means minus 2 minus 3 whole square plus y1 means 1 minus 5 whole square. That is equal to square root of minus 5 whole square plus minus 4 whole square. That is equal to square root of 25 plus 16. That is equal to square root of 41 units. Both answers will give the same. Hence, the distance formula we can write from the above. The distance formula we can write as square root of x2 minus x1 whole square plus y2 minus y1 whole square, or square root of x1 minus x2 whole square plus y1 minus y2 whole square. Here it is a solution for the second sum in the think and discuss of page number 163. Next, look at here in page number 164, example 3. In page number 164, example 3. Let's find the distance between the 2 points A. Distance between the 2 points we have to find out. So given that the 2 points are A 4, 3, B 8, 6. Here we are taking this point as x1, y1, second point as x2, y2. What is the distance formula? Distance between AB is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. That is equal to, we have to substitute this, that is 8 minus 4 whole square plus y2 minus y1, 6 minus 3 whole square. That is equal to square root of 8 minus 4, 4 square plus 6 minus 3, 3 square. That implies square root of 16 plus 9, that is equal to square root of 25. That implies 25, we can write it as 5 square, square root 5, cancelled, 5 units. It is a solution for example 3. In the same, now it's time to do this in the page number 164, that is page 164. Do this. So what is the first sum? Find the distance between the following pairs of points, right? We have to find out the distance between the points, that's it. Given that the given points are A 7, 8, B minus 2, 3, x1, y1, x2, y2, right? So we are taking these points as x1, y1, x2, y2, right? So the distance between the formula, distance between AB is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. That is equal to square root of x2 minus x1 means minus 2 minus x1 7 whole square plus y2, that is 3 minus 8 whole square. That is equal to square root of minus 9 whole square plus here minus 5 whole square. That is equal to square root of 9 square minus, it is even number, no, it will be minus of minus positive plus it became, so 9 square means 81 plus 5 square means 25. So that is equal to square root of the addition of these two, 106 units, square root of 106 units. Okay, that is the first sum. Here it is the second sum. So that is equal to, the given points are, given that the points are A minus 8, 6, B 2, 0, and the distance between AB is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. That is equal to square root of, here it is x1 y1, x2 y2, x2 2 minus of minus 8 whole square plus y2 0 minus 6 whole square. That is equal to square root of 2 minus of minus plus 8 whole square plus minus 6 whole square. That is equal to square root of 10 square plus 6 square. That is equal to square root of 100 plus 36. That is equal to the addition of these two, 136 units. Okay, so here we finished this. Do this. Now try this in the same page number 164. Try this. So here only one sum he was given, that is find the distance between a 1 comma minus 3 and b minus 4 comma 4 and rounded off to two decimals. Rounded off means in the root we shouldn't keep this number like this. Okay, we have to make this number into decimals. We have to make this number into decimals. Okay, so try this. So given that the points are a 1 comma minus 3, b minus 4 comma 4. Here we are taking it as x1 y1, x2 y2. Distance between AB is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. That is equal to square root of x2 means minus 4 minus x1 means 1 whole square plus y2 means 4 minus y1 means minus of minus 3 whole square. That is equal to square root of minus 5 whole square plus 4 plus 3 whole square. That is equal to square root of 25 plus 7 square. That is equal to square root of 25 plus 49. That is equal to square root of, by addition of these two. So here we have 4, 7, 74. By doing this square root of 74 using of this bar method in your 9th standard, the first chapter you have bar method. So you just take the 3 decimals like this. Okay, 3 decimals like this. Do this bar method. So you will get the final answer 8 8s 64, right? So here we have 10. So 2 decimals we have to take like that you just do the sum and you will get 8.602 units. Okay, then by using of this bar method you will get the answer for the square root of 74, that is equal to 8.602. You just recollect that this method is there in your 9th standard first chapter. Okay, that is bar method. Okay, by doing this bar method you will get the value, that is 8.0602 units. Okay, just like that. In think and discuss, in the same page you have think and discuss. Think and discuss. Sridhar calculated the distance between t 5 comma 2 or 4 minus 4 comma minus 1 to the nearest tenth is 9.5 units. So the distance he was given for these 2 points as 9.5, and also he want to check by doing these 2 points the distance also you will get 9.5 or not. We have to check these 2 points. First of all you just check the distance between these 2 points, then after you just watch the distance between the 2 points is also which gives the same answer or not. Okay, do you get the same answer that Sridhar got? Why? Okay, the first of all we will take this one. So in page number 164, think and discuss. So here we have, so first of all given that the points are t 5 comma 2 r minus 4 comma minus 1. Here we have x1 y1 x2 y2. The distance between tr is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. That is equal to, you just substitute these values, minus 4 minus 5 whole square plus y2 means minus 1 minus 2 whole square. That is equal to square root of minus 9 whole square plus minus 3 whole square. That is equal to square root of 81 plus 9. That is equal to square root of 90. Again you just do what is the nearest square root, that is square root of 81. Square root of 81 for what? 9. So by using of this bar method again you just do you will get 9.5 approximate unit. Approximately you will get the value that is 9.5 units. And also check these 2 points also which gives the same answer or not. Okay. While watching this question, you just check this 5, 2. Here he was given that minus 5, minus 2. Here it is negative numbers, that is minus 4, minus 1. Here 4, 1. Positive numbers. Let us check. So only the signs are different for these 2 points. You will get the same answer. Okay. Just let us check. Okay. So for the second, P is 4, 1. Q is minus 5, minus 2. X1, Y1, X2, Y2. Distance between PQ is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. That is equal to square root of minus 5 minus 4 whole square plus minus 2 minus 1 whole square. Just as usual from the above, minus 9 whole square plus minus 3 whole square. That is equal to square root of 81 plus 9. That is equal to square root of 90. Approximately it gives 9.5 units. Yes, the answer is same as the Sridhar got from the above. Yes, from the above, as the Sridhar got, the answer is same. From the above, the answer is same as the Sridhar got. Okay, so that is the solution for this think and discuss in the page number 164. Now let us enter into the example 4. That is example 4. That is, look at here, up to here we have only 2 points. Now look at here, we have 3 points. How we have to solve this kind of problems, right? Show that the points A 4, 2, B 7, 5, C 9, 7 or 3 points lie on a same line. Lie on the same line means collinear. Same line means collinear. So first of all, example 4, the given points are given that the points are A 4, 2, B 7, 5, C 9, 7. Collinear, all the points has to be on the same line. We have to prove that the points which is lies on the same line. Same line means, the points which is in same line means A, B, C on the same line. Collinear means collinear. What is the formula? How we have to find out this collinear, right? That is AB plus BC, AB plus BC, which is equal to AC. Then if the formula is satisfied, then it is collinear points. Okay, if A, B, C are collinear, it satisfied the condition, that is AB plus BC is equal to AC. To satisfy this condition, what we have to do? First of all, find out the distance between AB, then find out the distance between BC, then find out the distance between AC. Then check the points which is satisfied this equation or not. Okay, first of all, what we have to check? So the distance between AB, right? The distance between AB. So what are AB? A is 4, 2. B is 7, 5. Let us take it as x1, y1, x2, y2. Formula is x2 minus x1 whole square plus y2 minus y1 whole square. That is equal to square root of 7 minus 4 whole square plus y2 5 minus 2 whole square. that is equal to square root of 3 square plus 3 square, that is equal to square root of 9 plus 9, that is equal to square root of 18. So for this 18, I am writing it as 9 into 2. That is equal to square root of 9 square root of 2. I am separating these two. Square root of 9 means 3 root 2 units. This is distance between AB. Keep it in box. Now you just check BC. Okay, the distance between BC. What is B? B point is 7, 5. What is C? 9, 7. X1, Y1, X2, Y2. So, what is the distance formula? X2 minus X1 whole square plus Y2 minus Y1 whole square. That is equal to square root of, square root of Y2. Y2 means 7 minus 5 whole square plus 9 minus 7 whole square. That is equal to square root of 2 square plus 2 square. That is equal to square root of 4 plus 4. That is equal to square root of 8. That is equal to, we can write this 8 as 4 into 2. I want to separate these two. Square root of 4 into square root of 2. That is equal to 2 square root of 2 units. And thirdly, we have to check AC. The distance between AC. What are AC points? That is 4, 2, C, 9, 7. Take these points as x1, y1, x2, y2. What is the distance formula? That is x2 minus x1 whole square plus y2 minus y1 whole square. That is equal to square root of x2 means 9 minus 4 whole square plus 7 minus 2 whole square. That is equal to square root of 5 square plus 5 square. That implies square root of 25 plus 25. That is equal to square root of 50. We can write this 50 as 25 into 2. I want to separate these two. 25 into square root of 2. That is equal to 5 root 2 units. Here it is BC. Here it is AC. What is condition for collinear? Condition for collinear. What is condition? AB plus BC is equal to AC. What is AB? 3 root 2. Plus what is BC? 2 root 2 is equal to what is AC? 5 root 2. That implies 3 root 2 plus 2 root 2, 5 root 2 is equal to 5 root 2. Here these two are same. Hence, from above, the condition is satisfied. The condition is satisfied. Hence, the given points are collinear. Okay, here it is the answer for this. It is 4 marks question. It is essay question for you. You just look after again. I am explaining. Here he was given that 3 points, that is A, B, C. What we have to check, what we have to verify, that is 3 points are collinear. What is the condition for the collinear? AB plus BC is equal to AC. For that, to satisfying that condition, first of all we have to find out the distance between AB, then distance between BC, then distance between AC. You just substitute these all values in this condition. So AB, that is 3 root 2 plus 2 root 2, 5 root 2. Here it is 5 root 2 is equal to 5 root 2. Hence the from the above condition it is satisfied. Hence it is the given points are collinear. So example 4 is finished, right? Example 4 is finished. Now look at here. Are the points 3, example 5 or the points 3 comma 2 minus 2 comma minus 3 and 2 comma 3 form a triangle? If these three points are collinear, then the points will not form a triangle. Means this sum is also just do the above. As usual, you just do do this sum as usual, the model of this example 4. You just take these points and you just check the condition of this collinear. If the points which is satisfied the collinear condition, then it will not form a collinear, then it will not form a triangle. Otherwise, if it forms a collinear, then it is not a triangle. Then it is satisfied the collinear condition, then it will not form a triangle. Otherwise it will form a triangle. Just do this example 5 as per the model of this 4, example 4. Okay, from tomorrow onwards, tomorrow I'll explain from this, that is example 6, example 7, example 8, example 9, and then I'll start from the exercise 7.1. okay, I think I hope you understand well this.